Call it predictive programming or whatever you want, but I find it interesting that the butterfly effect shows up in different ways. Check it out. All right, y'all. So here we are at Yahoo News talking about physics again. I've been seeing a lot of articles, and maybe just because I read physics articles or, quantum physics studies or scientific, newsletters and journals, that it comes up on my feed as something of interest. So I'm going to share that interest with you all. And then I want you to let me know what you think about this one. This one kind of takes the cake out of my typical reading. Physicists say time travel can be simulated using quantum entanglement. The quantum world operates by different rules than the classical one we buzz around in, allowing the fantastical to the bizarrely normal. Physicists have described using quantum entanglement to simulate a closed time-like curve, in layman's terms, time travel. Before we proceed, I'll stress that no quantum particles went back in time. The recent research was a Gedanken experiment, a term popularized by Einstein to describe conceptual studies conducted in lieu of real tests. A useful thing when one is testing physics at its limits, like particles moving at the speed of light. But a proposed simulation involves effective time travel, according to the team's recent paper in Physical Review Letters, thanks to a famously strange way that quantum particles can interact. The team demonstrated that one could probabilistically improve one's past choice. Explained study co-author Nicole Younger-Halpern, a physicist at the National Institute of Standards and Technology in the University of Maryland at College Park. In an email to Gizmodo, though, she noted that the proposed time travel simulation has not yet taken place. In their study, the apparent time travel effect would occur one time in 4, a failure rate of 75%. To address the high failure rate, the team suggests sending a large number of entangled photons using a filter to ensure the photons with the corrected information got through while shifting out the outdated particles. The experiment that we describe seems impossible to solve with standard, not quantum physics, which obeys the normal arrow of time, said David Arvidson Schucker, a quantum physicist at the University of Cambridge and the study's lead author, in an email to Gizmodo. Thus, it appears as if quantum entanglement can generate instances which effectively look like time travel. The behavior of quantum particles, specifically the way in which those behaviors differ from macroscopic phenomena, are a useful means for physicists to probe the nature of our reality. Entanglement is one aspect of how quantum things operate by different laws. Last year, another group of physicists claimed that they managed to create a quantum wormhole, basically a portal through which quantum information could instantaneously travel. The year before, a team synchronized drums as white as human hairs using entanglement, and the 2022 Nobel Prize in Physics went to 3 physicists. Interrogation of quantum entanglement, which is clearly an important subject to study if we are to understand how things work. A simulation offers a means of probing time travel without worrying about whether it's actually permitted by the rules of the universe. Whether closed time-like curves exist in reality, we don't know. The laws of physics that we know of allow for the existence of CTCs, but those laws are incomplete. Most glaringly, we don't have a theory of quantum gravity, says Younger-Kaplan. Regardless of whether true CTCs exist, though one can use entanglement to simulate CTCs. As others showed before we wrote our paper, the physicist Kip Thorne presented a paper at the 13th International Conference on General Relativity and Gravitation. Thorne concluded that it may turn out that on macroscopic length scales, chronology is not always protected, and even if chronology is protected macroscopically, quantum gravity may well give finite probability amplitudes for microscopic spacetime histories with CTCs. In other words, whether time travel is possible or not is a quandary beyond the remit of classical physics. And since quantum gravity remains an elusive thing, the jury's out on time travel. But in a way, whether closed time-like curves exist in reality or not isn't that important, at least in the context of the new research. What's important is that in 1992, just a couple weeks before Hawkins' paper was published, the researchers think their Gedanken experiment provides a new way of interrogating quantum mechanics. It allows them to take advantage of the quantum realm's apparent disregard for time's continuity in order to achieve some fascinating results. The headline and text of this article have been updated to clarify that the team described a way that time travel can be simulated. They did not simulate time travel in this experiment. Albert Einstein to describe his unique approach of using conceptual rather than actual experiments in creating the theory of relativity. Let's see, what is a Gedanken experiment? So a Gedanken experiment is German thought experiment term used by Germans. For example, Einstein described how at 16 he watched himself in his mind's eye as he rode on a light wave and gazed at another light wave moving parallel to his. According to classical physics, Einstein should have seen the second light wave moving at a relative speed of 0. However, Einstein knew that Scottish physicist James Clerk Maxwell's electromagnetic equations absolutely require that light always move at 3 times 10 to the 8th power meters, 186,000 miles per second in a vacuum. Nothing in the theory allows a light wave to have a speed of 0. Another problem arose, and then it goes on to talk about, that, but I find that it's, something that is imagined. So let's go over to the article itself. PS journals. Right here, as you can see, physical review letters. And it's at the non-classical advantage in metrology established via quantum simulations of hypothetical closed time-like curves. And so this is the information that you can review to, look at the experiment. And I definitely want to hear from you guys about their imaginations, what I call their imaginations and thoughts on time travel. And all of those fancy words, of course, are in the realm of science. You can go look them up. But it's interesting how that whole thought process or theory comes out to be like, we can go back in time, right? And if you're not paying attention and you don't understand what's being said and that this is all being theorized, you would look at the article like, oh, we can do that now? Wow, we've advanced in science. So I want you to be paying attention and then let me know your thoughts. All right, talk to you later.
Remember when we were kids and I used to have those blackouts? Well, some of those memories have been coming back to me.
There are moments in life we choose to remember.
Do you think that we'll be together forever?
And some memories we can never forget.
All I know is that by reading these journals, I might be able to get Kaylee back.
I'd think twice about what you're doing. You could wake up a lot more messed up than you are now.
I haven't seen results like this before.
But what if you could go back in time?
You are completely relaxed. Think of it like a movie. You can pause, rewind, or slow down.
Could you save the one person that mattered the most?
Honey, are you all right?
You. Incredible. I lost you once, and I'm not losing you again.
Evan, you never lost me. What are you talking about?
You got a nice life.
You stay away from us.
It's been a while since I could.
What about Kaylee? Is she all right? If I go back to the beginning, I might be able to save her. Just tell me if you see anything weird. Weirder than this. Kaylee, that you were happy once. With me.
Why don't you go back and save me?
How are you doing this?
You wouldn't believe me if I told you.
You can't change who people are without destroying who they were.
Every time I try to go back in time and help someone, everything just goes wrong.
Oh my God, what did we do?
You can't play God.
The Butterfly Effect.